I believe for you.
Got it.
Okay, so my question was, for example, in the construction of the speakers between the series T, X, and S, if there was any reason they were constructed differently. Yeah, I believe. Yeah.
Yeah, I'd say that, of course, that the price points of these three ranges of products are very different to each other. That's partly due to the feature set that you see in each range. So as you go up the range, you'll see in the S series, for example, there's delay and far more EQ, and in the T series, there isn't so much to play with on the back panel. So that's understandable. If you were to buy an expensive BMW and compare it to a really bottom of the range, I don't know, Fiat Punto or something like that, clearly you wouldn't get as many knobs and buttons to play with on the cheaper car. So that's one thing, but also the quality of materials again, and this is where the car analogy is very good. Of course, the cost of the parts in a BMW are far more expensive than the cost of the parts in a Fiat. However, both cars do move. In other words, they both play sound like loudspeakers would. But the S series would be a much smoother ride, and you'd feel far less exhausted by the end of your long journey. And maybe Kevin's wishing he has a BMW instead of a Fiat now after spending all day in a car. But yeah, that would be the advantage of buying an S series compared to a T. Is an S series will play louder, it will play with lower distortion, it will have a flatter frequency response. It's just a better speaker because we've used better parts and we spent more money on all the extra little bits and pieces that allow us to do a good job. So that's the fundamental difference.
Cool. Does that answer your question, Rodrigo?
Yeah. I was wondering because I've heard the X series tweeter compares to the T series in size also. I know it's a different tweeter, but I don't know exactly
Yeah, just because something's the same size doesn't mean it's the same quality. So you know, you can buy a Rolex watch, or you can buy a really cheap watch from the supermarket, and they're both physically the same size, but one's clearly better than the other one is. They both tell the time, but one's much nicer to wear on your wrist. Is that a good analogy? I'm not sure. Trying to find a good way of explaining it.
Yeah.
So yes, the distortion on an A series, AX series, or an S series tweeter is going to be lower than on a T series. I mean, you are getting something when you pay more money. We're not just giving you the same parts and taking more money and putting it in the bank and saying thank you very much. That's not the type of business we're running. We want to give you value for money, whichever product you buy.
Okay, thank you.
One example, maybe if I can just quickly jump in, would be the size of the magnet that is built into an AX series tweeter versus an S series tweeter, because the tweeter has to handle higher volumes and you need the magnet to do that.
Yeah, that's a good point. Just because the front looks the same size doesn't mean that what's going on around the back is the same size. So there is clearly things happening inside. And another example of, just to emphasize what Anna said, is you've also got the amplifiers, for example. They will be bigger, even in the same physical size loudspeaker. We just put bigger amplifiers in a more expensive product. And then we're able to maximize what we get out of the more expensive drivers that are in the better product. And so the transient performance will be better, and the maximum SPL and the low frequency cutoff will be lower. So it's just all better in a better quality product.
Okay, thanks.
Okay, I have one question for you, Mr. Goldberg.
Yes, Herr Bent.
Okay, if you're looking at the construction of a hi-fi speaker and a construction of a studio monitor, are there many differences in the way in which they're put together, or what would you say are the most obvious differences?
Yeah, in the sense that you've got something round and wobbly in the front. Yeah, they're basically the same. What you do see with hi-fi loudspeakers is that they're not built for accuracy. They're built for, I would say, two reasons. And I don't wish to put hi-fi speakers down too much by this statement. They're built for two reasons. One is they look good. So they are often pieces of furniture. They are lifestyle devices. If you buy, for example, Bang & Olufsen or Burmeister, who are not far from where Adam is in Berlin, these are
around the corner from my
yeah, just around the corner. Yeah, really not far. So these are clearly either making a statement about who you are. I've got Bang & Olufsen. Oh, that's good. That means you are upper middle class and you've made it. And you're comfortable, and so on. Or you're Burmeister customer and you've just spent a lot of money on a product because you want to, because you can afford it. So that's one thing. The other thing is, of course, one is listening for pleasure, not accuracy. And listening for pleasure is not necessarily about having the flattest frequency response and the lowest distortion and so on. However, what I have found is that the better quality the loudspeaker is in terms of its accuracy, a byproduct of that is that it does sound better. So if you have a really low distortion and a really flat frequency response in the room, it will actually sound very good. So what exactly are the hi-fi people trying to do that isn't that? They're probably putting some shape on it. It's then not accurate. It's not a true representation of your original signal. And I'd rather heard what the artist intended than what the loudspeaker designer intended, because they are not the same thing. So with a flat studio monitor or any flat loudspeaker, you're getting to hear the original material as it was. And of course, that's what we're all here for. We want to create music. We want to listen to music with accuracy so that we can make appropriate listening decisions or appropriate mixing decisions and audio decisions. But yes, at home here, I have studio monitors. And funnily enough, when we go to see our friends and they put their hi-fi on, play some background music, my wife kind of nudges me and says, "Those speakers don't sound very good, do they?" Because for over 20 years, she's been listening to studio monitors. Her reference is now studio sound quality. And that sounds good. And she's happy with it. She's a preschool teacher. She's not an audio expert, but she knows when it sounds bad and she doesn't like it. And so if you get used to high sound quality, then you want to keep it that way. Okay, I don't think that mostly answers the question. So yes, it's lifestyle, the look of the product, what it's saying about you, and its accuracy. Those are the fundamental differences. Oh, the other thing is, of course, to make a beautiful looking piece of furniture, it's not cheap. So you often find that furniture manufacturers also have a sideline of making beautiful loudspeaker cabinets. So real wood veneers, gold plated, this, that, and the other, screws and washers and what have you. It's all a lot of money, but it doesn't actually add to the sound quality in any way. It's expense for the sake of it. Rolls-Royce, it drives down the road, it will get you from A to B, but it's a very expensive way of going to the shops to get your daily food shopping. So yeah, would I spend the money on a hi-fi speaker when I know what's going on in there? Well, probably not. I'd rather buy a studio monitor. It's far better value for money if sound quality is the most important thing for you. And certainly for anyone creating music, unless you have to, I wouldn't bother using a hi-fi speaker because it's not as accurate as a studio monitor.
Excellent. Thank you very much. Cheers for that, Andrew.
Okay.
It sounds like I'm going to have to go.
Oh, there's one more thing. Most hi-fi speakers are passive, and we've just talked about that. Active is better.
Interesting. So from my terminology or my way of thinking is that a lot of people buy passive and buy the incorrect amp, which is of no benefit to them.
They're buying an amplifier, and any amplifier designer will tell you the biggest problem they got is they don't know what you're going to connect to it. So they have to design the amplifier output to work with anything. because anything could be connected to it. We can design our amplifiers to work perfectly with the one driver that we're going to connect to it. We know exactly what the load is because it's our driver. So that makes the whole design exercise easier, and the quality level goes up as a result.
So do you reckon that hi-fi will eventually go 100% active? Because they had a really fun period where they were very offish about going active. Like
it is interesting, actually, and in a previous company I worked for, 10% of large studio monitor sales were sold through one hi-fi dealer in Munich. The hi-fi customers are actually starting to notice that studio monitors are better. They're way better value for money, and they're actually buying them because they are studio monitors and not hi-fi speakers. So actually, those types of customers who can put up with a box that's maybe not the prettiest on the planet, you know, it's not a beautiful piece of furniture, it's a working product. If they're prepared to put up with that look, then they will go in that direction. Of course, the other thing that's come along in the last I don't even know if it's been a sliding scale, it's been going on for decades now, is that the 2-channel vinyl loving big Magna Planar speaker type hi-fi customer, they're just going away. People aren't buying that stuff anymore. People would rather go and buy an Echo Dot or some other smart speaker. They stick it in the kitchen or in the corner of the living room, and that is their hi-fi now.
Yeah.
Yeah.
It doesn't complement the sound.
No, and it's okay for reproducing an Alexa query. So, you know, where can I buy such and such cheaply? Yeah, sure, it's okay for that. But and for background music, fine. But yeah, if you want to sit down and listen to quality music, yeah, actually, studio monitors make very good products for that.
Excellent. Okay. Do we have any more questions on the first video, or is everybody pretty cool with the first video now?
Oh, there's a hand. Someone's not happy.
My greetings to everyone here.
Hi, Francisco.
Good evening. As I can see, you are in a very dark light, and we are like in the noon here in Latin America. I've got a bunch of questions. But the first one, and I don't know if it's exactly from the first video, but I would prefer to difference in the real life use of vertical versus horizontal orientation of a speaker.
Mm-hmm.
Like, what's the deal? I mean, if there is the same references, same features of the monitors, but as a user, as a producer, or someone who's making music in that area, which one should I go for? Thanks.
I think when you're choosing any loudspeaker, there are some things that you have to decide as the customer or the user. One is, how much space do you have? And if you only have this much width to put a loudspeaker in, you're not going to use a loudspeaker that's this big. So that's pretty clear. If you've got lots of vertical space, then you would use a narrower speaker. If you've got the horizontal space and vertical space is a problem, then you use a wide loudspeaker. So that's a fairly obvious statement, I think. Of course, another thing is budget. One big woofer is cheaper than 2 smaller ones. I mean, that's just an economic fact. So sometimes the price of products will be a factor. In fact, it always is a factor because you have to pay for it. And if you've only got so much money in your wallet, you can only afford a certain size of loudspeaker. Another factor is in purchasing loudspeakers is how loud do you want to play them? If you're using them at the sort of distance I've got in front of me, my studio monitors on my desk are about 80 centimeters away from me. I do not need a main monitor with dual 18-inch woofers in it. So I can give Genelec a miss on that one, for example. And then the other factor is low frequency cutoff. If you are doing guitar and female folk music, then you don't need 20 hertz. It's just unnecessary. If you're doing EDM and movies with big explosions at the end, then clearly you need some bass in there. So then a tiny little T5 on its own is not going to do the job. So it's going to need some help. So once you've answered all of those questions, you usually find that an appropriate product will jump out at you, whichever company you're looking at. So then what's the advantage, or what's the real difference in the horizontal versions versus the vertical versions? Well, yeah, you could take a vertical version of the product, and with that you get a wide horizontal dispersion and a narrow vertical dispersion. So if you look at the picture behind Kevin, you can see that he's sitting. Oh, look at that, there you go. He was sitting in the right place for one of them. It's not an ideal stereo pair there. But yes, he's sitting basically in front of the speaker, and that's great. If he moves left and right along the mixing desk, then the distance difference between the two drivers and his ears is not changing because they are vertically orientated. And that's good. If he was to rotate it 90 degrees, which you probably can't do so easily, but imagine turning the loudspeaker 90 degrees and then he moves left and right, then he's going to get closer and further away from the two drivers. And when you're off axis from the two drivers, what will happen is you've got the frequency response is nice and flat when you're on axis, but at the crossover frequency, if you're off axis, you'll get a big notch there. And this is the same for any two-way speaker, and actually any three-way speaker between the mid-range and the treble driver. So this is why you should always use a two-way speaker vertically, like you see in Kevin's picture there. That's perfect. Well done. You set your speaker up correctly. So never put a two-way speaker on its side. I see it all the time. I was about to say I see it on the front of magazines, but it's not on this one. But if I flick through this magazine here, I will eventually find a two-way speaker on its side, and it's just wrong. Don't do it. Okay, and the same with three-way speakers. Always place the mid-range and the treble and the mid-range vertically orientated. It just works better. And also, of course, you can see that the waveguide is wider horizontally and narrower vertically. So if I place the loudspeaker on its side, oh, thanks, Arna, you've just moved over and illustrated it even better there. So yes, if you place it on its side, you end up with a narrow horizontal and a wide vertical. So now your floor and ceiling reflections are increased and your listening area has been narrowed. And that's completely the opposite of what you want to have. There's only one circumstance I can think of where that makes sense, which if you go into the broadcast industry and you're sitting in an OB van, so you're doing outside broadcast, you're in a van, you have no space. The listening position is extremely well defined because you have no space. You can't move around very much. If you do, it's only to do that, and then you come back and then you do that. And also the sidewalls are very close. So by having a narrower horizontal, you actually, you reduce the sidewall reflections, which is a good thing. And as you are locked onto the center position anyway, you don't have the off-axis problem because you're just not moving around very much. So in OB vans where there's so little space to install anything, it can be a good thing to put them horizontally. But that's the only example I can think of that makes any real acoustical sense. In all other cases, all two ways should be placed vertically. Okay. Oh, there's one disadvantage of that. If you are doing 3D audio or surround sound where you've got a center speaker and you want to see into the room, the live room, and you've got a nice big speaker in front of you, that can be really annoying. So that's why people often use these horizontal designs in the center, so then they can see over the top and see what's going on in the other room. Okay,
Excellent. Thank you, Andrew.
thank you.
Okay.
Are my answers too long, by the way? I'm talking a bit too much, maybe. It's okay.
No,
All right.
I myself personally I'm learning quite a bit. They're really, really informative. So thank you.
Good. All right. Thanks. I'll carry on.
Shall we shoot straight into the second video?
Yeah, there are not any further questions. Then maybe let's move on. Also, if there are any follow-up questions today or tomorrow, please just send us an email or just your university tutors. I'm sure there's a way to answer them if you just come to think of them after the call or something like that. Just being a bit aware of time because yeah, it is getting late in our part of Europe. Yes, Simon.
Yeah, hello. I just have a quick question. So it's about the reflections in the room, where in the corners it gets like they say it get hot, because the low frequencies get stuck in there. But my question is like, what happens in the center of the room? Is there also the frequencies stuck in the center or only in the corners?
Now, what happens in the, well, when you take a loudspeaker and you place it next to a wall, all the sound that was going backwards now has to come forwards because it can't go backwards. I'm assuming that this is an acoustically perfect wall. So this is your exam question situation here. So perfect wall, all the sound going backwards has to go forwards. So now you've got 1, which is the sound coming out of the speaker, plus the 1 that was going back is now coming forwards. 1 plus 1 is a doubling of the sound pressure level. So that's plus 6 dB. So in acoustics, 1 plus 1 equals 6. Does that make sense? Okay, so now let's move the speaker all the way to the side of the room, but keep it up against the front wall. So now we've got a side wall and a front wall. So all the sound that was going sideways now has to come into the room. So now we've halved the space again. So we've gone from what was called half space to a quarter space. And now you've got 4 times the energy. So now you've got 12 dB. And then if you put it all the way up into the corner, up there or down there, then you've got the nightclub situation where the speaker's in the corner and all of that sound. And you do the maths and you'll find you end up with 18 dB. So that's why all speakers in nightclubs sound so boomy and horrible, because they're stuck in the corner out of the way, so that there's more table space. So that's what's going on. Now this boost only happens at the lower frequencies, because the low frequencies are omnidirectional. The sound radiates from the speaker in all directions. As you go up in frequency, the speaker becomes more directional. So there is less sound going backwards and off to the side. It's more coming from the front of the loudspeaker. So that's why you'll see that the bass goes up, but the mid and the treble level doesn't. So that's why you get very bassy sounding loudspeakers. So that, of course, would be great for a subwoofer because it would just sound louder. For a loudspeaker with mid-range and treble, that's pretty bad. Now, what we can do is that with a loudspeaker placed next to a wall, the bass has gone up. What we can do is turn it back down again with the switches on the back of the loudspeaker, or dialing it in on an S series using the back panel controls. And then the loudspeaker is then playing less loudly at low frequencies, and we end up back to a flat frequency response. As the loudspeaker is working less hard at low frequencies, the distortion goes down as well. So actually the loudspeaker will play cleaner than it did when it was far away from the wall. And you've still got a flat frequency response. Now, in a passive speaker, going back to that topic, to modify the frequency response is very difficult in a passive crossover. With active filters, it's really easy to do. We just change a resistor or a capacitor. It's actually, from an engineering point of view, it's not hard to do this. So that's another advantage of an active system. And then the other question you asked is about placing a loudspeaker in the center of the room. what happens is that assuming your room is nice and symmetrical, in the center of the room, if I turn to the camera and look this way, you'll imagine that the walls are where the edge of my screen is here. So there's my left and right walls. You'll get a pressure maximum on the edge of the room. And then as you go into the middle, it will go down like that, and you'll have a pressure minimum. So you can imagine a graph that looks a bit like this. If you place your subwoofer right here at that frequency, which is, see, this is a quarter wavelength, and there's the other quarter wavelength. So the width of the room is half a wavelength. And it's relatively easy maths to do this. I'm sure you can manage that in your spare time. You can calculate what that frequency is, and the subwoofer will be driving really hard at that frequency, and nothing will happen. Well, not nothing, but not much will happen. You won't hear much bass at that frequency. If you take a step to one side, and this is what I usually do, I put the subwoofer in the middle on the floor, and then I push it off to one side about that far. So I'm sort of about a third of the way across the room. So I've got the subwoofers here, and I've got 2/3 on this side and 1/3 on that side. It's a very good place to start, because then you're avoiding that first minimum here. The next minimum is at twice the frequency. So you're going to get a minimum about here, here, and here. And then the next one up, well, you're probably out of the passband of the subwoofer anyway. It doesn't matter anymore. So that's a very good place to start. And then I might move it around a little bit after experimenting. In other words, when I say experimenting, I mean measuring. I always set up subwoofers by measurement, because it's very unreliable to listen. So you can get Room EQ Wizard for free on the internet. Find yourself a reasonable measurement microphone, and when I say the word reasonable, that means not Behringer. So get yourself a reasonable measurement microphone and a simple sound card. You can calibrate the sound card to be flat, and if you've got the response of the measurement microphone as well, some measurement microphones come with a calibration curve as well. So if you can get that as well, you can put that into the measurement system, and then you can get a reliable measurement, and then you can actually see what's happening when you move things around. And it's much easier to do something about it if you can measure it and see it. If you're just listening, you will imagine that it sounds good, and maybe it does, but it probably doesn't. When you measure it, you'll be shocked what you actually see in the room. So yeah, that's how I do it.
So would I be correct in saying that the first rule of thumb is not to have it center of the actual room?
Yeah, subwoofer, do not put it in the center of the front wall. Put it off to one side. And always put a subwoofer up against the wall, because these are free decibels. You don't have to pay for this. You put it next to a wall, the level just goes up. You don't have to pay a penny for that, which is fantastic. I like free. That's good.
Okay. So what you got? So you have a question for us? I've got you. I can see your hands up.
Yeah, thank you.
Okay.
I have there was something that I didn't understand perfectly, and it's about the loudspeaker and the distance between the wall. Because if I remember well, it's supposed to be like a meter or something like that of the wall.
Yeah.
But what happened with the smaller spaces? I mean, like if I about loudspeakers and my room is very small and I can't take the space. There is is there a solution for that? Because the back part of the loudspeakers, it will be a problem, no?
Yeah, so I'm going to draw something quickly on the back of an envelope. So excuse the very amateur drawing here. But I've got a loudspeaker on a stand. There you go, next to a little bit far out from the wall. I'll draw some little drivers on so you know which way round it's facing. So the sound is going to come out from the loudspeaker like this. towards the listening position. Let's draw a human being with an ear and some hair, because all sound engineers have lots of hair. So there we go. That's the listening position.
Or
so
not at all.
Yeah, well, yeah, most. So then the sound will also travel backwards towards the wall. So I've drawn another arrow on there. I did this once with green lines and red lines in Canada. And I said, yeah, the green sound goes this way and the red sound goes that way. And then someone at the back of the room was, sorry, I'm colorblind, which line is which. Anyway, the sound will, again, let's use the perfect wall. So this is an exam question. So we've got a perfect reflection off the wall. The sound will travel back again towards the listening, towards the front of the speaker. And when that reflected sound is out of phase with the sound coming out of the loudspeaker, you've got this going on. And you can imagine if you add those two lines together, you end up with a flat line. So you can't equalize that. You can't put a graphic equalizer in there or a parametric equalizer and say, well, my problem is at 100 hertz, so I'll just boost 100 hertz. Because all that happens is you end up with a bigger line doing that. The reflected energy gets bigger as well. So instead of 1 minus 1 equals 0, you've now got 2 minus 2 equals 0. So the loudspeaker's working harder and you just got the same cancellation. And if you move around in the room, it doesn't make any difference because the relationship of the loudspeaker to the wall has not changed. It will still be there. And that's a big clue. If you've got your measurement mic, move it around, move it 50 centimeters in either direction. If the notch in the frequency response from that cancellation doesn't change, you know that it's the wall behind the speaker. You can also just imagine that this is a quarter wavelength plus a quarter wavelength equals half a wavelength. You're out of phase. So if you just measure that, multiply by 4, and then calculate the frequency, you'll see the notch right there. And so this is actually very predictable. And so the solution is you put a lot of fluffy stuff here, something to damp that sound. So if you can get rid of this sound, then the reflection's gone away and you just got the direct sound coming from the loudspeaker. In practice, you can't get enough fluffy stuff back there. So the better way to do it is to take this loudspeaker and move it next to the wall. And in a small room, that's the only place you can put a loudspeaker because you, as a human being, need to be far away from the wall. So I'm now going to draw another wall on the other end of the room there. And guess what? Exactly the same thing's happening here. You've got the same reflection off the wall and back to the listening position. And when that's out of phase, you end up with a notch based on the wavelength or the quarter wavelength. Now, if you move the microphone around, then you go forwards and backwards here, the notch will move in frequency. So now you know that it's either not moving, it's the front wall, is moving, it's the back wall, but usually you've also got the side walls and the ceiling and the floor reflection to look at as well. So it gets a little bit complicated. But what you need to do is be far away from the back wall. So never put your head next to the back wall, always be in the front third of the room. And if you go to the classic old big rooms that you see, well, they're not in New York anymore, they've all gone, but there are still a few in London. Kevin knows Air Lyndhurst probably, and Abbey Road and places like that. The back wall is 4 meters away. It's a long, long, long way away from your ears because 4.3 meters is a quarter wavelength of 20 hertz. So the rear wall is over 4 meters away. And so we get rid of the rear wall reflection by having it a long way away. And then we get rid of the front wall reflection by placing the loudspeaker next to the wall. And of course, next to the wall can also mean in the wall. So that's why big main monitors are always in the wall, because it gets them out of the room and then you have no rear wall to worry about, or sorry, wall behind the speaker to worry about. So that's what's going on there. Of course, the problem in smaller rooms is that I mean, this is an example of that. This room, you probably can't tell from the camera and the angle of the lens, but this is 4 by 3 meters. It's not a big room. So clearly I cannot be 4 meters away from the wall behind me because the room's only 4 meters long. and also the sidewall. Well, I'm even firing across the room, so this is not a studio. This is a home office. I don't do any mixing in here. I'm just working. But yeah, the sidewalls are a problem. The ceiling, the floor, the wall behind me, it's all a problem. It all adds up. And the closer these walls get, because the rooms get smaller and smaller, the higher the frequencies that you see these problems and the more audible they get. And this is the trend that we see across the world, across all the studios, is the rooms are getting smaller and the problems are going up in frequency, and then they're more problematic to fix because they're so audible now. And in the old days, people had big rooms, big speakers in big rooms. There's nothing like a big system in a big room. It just sounds amazing. And now you know why.
So it's easier to set up a bigger room rather than a smaller room?
Oh yeah. I went to, I've been to Air Lyndhurst and I've also been to Skywalker Ranch, both world-class quality rooms. It's very simple. You take the near field monitor, put it on the large Neve mixing console, because they've both got Neves in it. Take the low mid control or desk control, whatever it may be called, put it down to minimum, done. Go and have an early tea break. You don't have to do anything more than that. You're only compensating for the desktop loading. That's it. Very, very easy. So the more professional the facility gets, the less work you have to do on it. It's small rooms that suck so much. And that's where everybody's mixing these days, which is a terrible shame.
Including me.
Yeah, there you go. You suck, Kevin. I mean, your room sucks.
Oh, it's very small.
Yeah.
Excellent. Okay. Right. Rodrigo.
Just expanding on that idea of the subwoofer frequencies in a small room. I kind of went out of my way to see another ADAM videos where Stefan talks about this, but I didn't. I was thinking, because I'm having acoustics class, so I always thought that the subwoofer in the corner of the room would be problematic.
It can work. It depends on the room. So a room consists of walls and ceilings and floors, well, a ceiling and a floor, multiple walls, and those surfaces can all be made from different materials. So there could be anything from brick and concrete at one end, which is acoustically extremely heavy, through to, let's take the classic Japanese tissue paper at the other end, where it's basically invisible. Now, no one's making studios out of that, but it could be, for example, this room here, this is a wood and gypsum construction, which is very typical for Finland. And you see that in America a lot. In a studio, it should be multiple layers of gypsum, and heavily braced as well, more wood holding it in place than a normal builder would use. So the more solid the wall, the more boost you'll get off it, and the stronger the reflection you'll get off it if the sound is bouncing off it. And then, of course, you've got the acoustical treatment that you put in the room. That will have obviously some effect, which is why you do it in the first place. And all these things go towards giving you an in-room sound. Now, if you were to place a subwoofer in the corner, what you will find, on the floor in the corner, because that's usually where they go, you'll find that you are exciting all of the room modes really strongly, and that may or may not be a good thing. So it very much depends on the solidity of your room and where all of those frequencies are based on the size of your room, the dimensions of your room. And then whether that works or not. So I would just be prepared to move subwoofers around until you get a good position for them. If you've got room modeling software, you can actually make a reasonable prediction as to where the subwoofer should go. If you've already got a room, it's quicker just to put the subwoofer in and measure it. What's the point modeling it when you've got the real thing in front of you? The only real reason for modeling a room is because you haven't built it yet and you want to build it right first time. But usually people are placing loudspeakers into already existing rooms, so then there's not really much point in modeling. But yeah, modeling is possible to do, and so is measurement, but not measuring and not modeling, I wouldn't recommend that.
Yeah, because we then now enter to face alignment problems with the subwoofer and the speakers. So I have to find a good space vertically and horizontally. In relation to
measure
my,
measure it so you can be really sure that what you're doing works. Hey, one more tip, I think we're sort of running out of time now, is that subwoofers are quite big and heavy, and so moving them around is not much fun. So better would be place a subwoofer on your chair where you're going to sit and move the microphone around instead. It's much easier to do. And then when you find a good position for the microphone, swap the microphone and the subwoofer, and that should work. And then you just have small adjustments from there.
Okay, thanks.
Who's it? Andrew, thank you so much. One quick question. You're coming to England in April?
I will be over.
You're going to have a lovely evening over at my studio.
Bring your measurement microphone.
I might have to forget it. Yeah. So, oh, sorry, I forgot to bring my mic. Yeah.
You've run out of time. Okay, right, guys. How are we looking? Any more questions on the second video? It seems like everybody understood the second video, which is pretty cool.
That's cool. Yeah, because that was, I guess, the most tricky video. The third one that we had, and we kind of already touched on that, is what makes a good speaker and what to look out for. Maybe your take on that, Andrew.
Yeah, so I would say the first thing is, let's start with a tweeter, because why not start from there? So the tweeter should have a waveguide on it, and there are some products that have no waveguides, others that have what I would just call a dimple in the front panel. It's just so shallow you can barely see it. It's more of a cosmetic shape, and others have proper waveguides. So of course we have proper waveguides on our products. So what does a waveguide do? Well, it basically tries to guide the sound, which is a wave, in roughly the right direction. Where acoustically it is a horn, just like you see on a PA system. But if we were to call it a horn, you would think of, I don't know if this is going to work through the microphone, but can you imagine this sort of sound quality? You know, you don't really want that sort of horse race PA sound, do you? That's not very good. What we're doing is gently guiding the sound in the direction of the listening area. And what we're doing is reducing the sound that goes to the side walls and ceiling and floor and so on. So that's the first thing. That then allows the loudspeaker to be less sensitive to the quality of the acoustics in the room. So if you take the same loudspeaker and move it to another room, you're more likely to get a good sound quality than if you have no waveguide at all. Conversely, if you take the same loudspeaker and move it around in the room, if you are doing surround sound or 3D audio, you probably have the same loudspeaker in many positions in the room, and it would be nice to have a good consistent sound quality from all of the boxes. So that's one thing. So look for a quality waveguide, not just a dimple on the front panel or nothing at all. The bass driver needs to be robust because it's got to do a lot of work moving backwards and forwards. So can it actually move sufficiently to do the job, to actually move the air? Because, well, I play bass guitar, and when I was gigging years ago, it's like standing on a windy mountaintop. It's just fantastic. All that wind passing past me. That's what bass is. So it's controlled wind. And then, of course, to support that, we've got the ports on the bottom of the products or around the back in the case of the T series, and that gives the extra low frequency sound pressure that we want to see, so that we have decent. You can have bass extension, but if you don't have any level at that low frequency, there's no point having it at all. So that's where the bass reflex ports come in useful. Then, of course, you want a nice solid cabinet. So that's if you people do drop products occasionally. It's unfortunate, but you know, things slip out of fingers and things fall off loudspeaker stands. Now, we don't guarantee the product will work after a 2-meter drop, but it would be nice to think that perhaps it can. But yeah, sometimes people will put things, just throw it onto the surface. cartons get thrown around when they're being transported. So the product must be physically robust. So things like the base driver magnet mustn't move on the basket. Otherwise, you end up with a rubbing voice coil and a service case. You'll just hear a lot of rubbing distortion sounds from your woofer. So that's not good. So yeah, the woofer should be robust. And then, of course, if there's a paint surface finish or a vinyl wrap on the lower price products, then that needs to be solid enough to survive life in a working studio. And if you go to broadcast centers, for example, they are moving the product around all the time. So yeah, they need to be quite robust to scratching then. And then on the back, we want to have nice solid controls. These are not sort of fiddly things. They're really set and forget controls, but they shouldn't fall apart in your fingers when you use them. So there's that as well. And then yeah, amplifiers that are big enough to do the job, and suitable set of controls on the back so that you can adjust the loudspeaker in the room. Because every room is different. We can't guarantee that the sound is the same in all rooms if we don't have many controls to play with. Okay, Kevin's put his hand up. I think he's had enough of listening to me.
Oh no, definitely not.
Oh.
What's it?
Okay, well, that's basically it, I think. Yeah. Oh, one more thing, mounting hardware. You don't see it on the T series because they tend to be just placed on loudspeaker stands or desks. That's fine, but as we go up in the range, you'll start to see that particularly for the S series, you'll see that we have things to hang stuff off ceilings, because we see that we see installations like that in products like that. So we have the mounting hardware to help our customers with that.
Okay, right. Any more questions from you guys? Because if you haven't, I've got one more just to close the evening.
Mm-hmm.
Mr. Goldberg.
Yes.
Ported cabinet or closed cabinet?
Ported or closed. Now, the thing in acoustics, well, the first thing is, this is a little acoustical joke. How do you know you're talking to an acoustical engineer?
They clap when they enter a room.
No, that's a sign that they're not an acoustic engineer. There's no bass in a clapping sound, is there? So you can't test the low frequencies. So I'm going to dispel that myth already. When you ask an acoustical engineer a question, the answer always starts with, it depends. Because acoustics is all about trade-offs, or loudspeaker design particularly is about trade-offs between one thing and another. So we might want to have a small cabinet, and the cost of that, well, the advantage is, of course, it's easier to move around, it's lighter to mount, doesn't cost as much, and so on. But the cost of that is the base extension is reduced and the max SPL goes down. So there's your trade-off. And if one thing is more important than another, then a certain size of product will make sense. Another vented and sealed cabinets is a very good example of a trade-off again. So we add the port in the cabinet so that we get some help at the very lowest frequencies that the loudspeaker is trying to reproduce. The cost of that there are two costs to that. One is, well, maybe three. One is we've got to design a port. So that's not very easy to do. But let's assume that we can design a good one. The next thing is that I need my little envelope again. Oh, there we go. So I'm going to draw a quick graph there. I didn't draw that very well, my pen ran out. So there's our low frequency corner. Hope this is the right way around.
Yeah.
And you see the slope of the loudspeaker there.
Yeah.
Right. So if you've got a vented cabinet, that will be a fourth order slope. What's called fourth order, right? So that's rolling off at 24 dB per octave. So if you go down, if you halve the frequency, the level would have gone down 24 dB. Okay. Don't know if you can read my writing. Is that the right way around on the camera? It's mirrored on mine.
Yeah, looks good.
Yeah.
Oh, okay. Well, I can't write backwards. So if we take a vented, a sealed cabinet, you'll get a second order roll off, which is 12 dB per octave. And so it's going to look a bit more like that. So it's shallower. So you think, well, okay, I'm actually getting a bit more bass out of that. But of course, it's actually inaccurate bass because it's still rolling off. The accurate part starts here and goes up. The advantage, though, is that there's a thing called group delay, which is how long it takes the sound to pass through the loudspeaker. And in a sealed cabinet, the group delay is lower because it's a second order system. In a vented cabinet, it's a fourth order system. The group delay will be higher. And that's why when you talk to sound engineers, they will say a sealed cabinet sounds faster, tighter. These are the words that sound engineers use. And in a vented cabinet, people will say it sounds loose, flappy, slow, those sorts of words. Now, those would be extreme examples. So if you had a badly designed vented cabinet, yeah, it can sound a bit late and slow in the bass. If you've got a really well-designed vented cabinet, it can sound as good as a sealed cabinet. But of course, the cost is we've got another part to design and put in, it's higher cost and so on. But you do get more max SPL out of a vented cabinet than a sealed cabinet. So there's a whole bunch of things going on there. And again, it depends on what you're trying to do. If you don't play very loud, you don't have very bassy music, then perhaps a sealed cabinet works for you. If you're doing electronic dance music, then a sealed cabinet's is probably not the right choice. You probably need a vented cabinet. Okay.
That's brilliant. Thank you very much.
Yeah.
Okay. Right. So guys, next move is that we will be uploading the questions. Will it be tomorrow morning on?
Oh, they're already online. So if you
Ooh,
can
so-
check out the landing page, which I put in the chat at the beginning, or just go back to the emails that you received from the universities. So there's a link to the landing page on there. And there's, where you can also find the questionnaire. And have your take at it.
That's absolutely superb. And what are we looking? Another 10 days before we come back with the results, 10 to 14?
That should be doable, yes.
Okay. And then we will definitely come back to you guys within about another 10 to 14 days with the results. Let's see who's passed. Okay. So if we can give it up for Andrew, Mr. Goldberg, thank you so much for this evening.
Thank you so much.
No problem. No problem. Absolute pleasure.
Really, really cool. Thank you so much. And I thank you guys for attending this evening as well. And we look forward to speaking to you all in, another couple of weeks. So thank you very much and enjoy the rest of your day.
And guess what I'm doing next? I've got some snow to move. I've got about that much to shovel.
Yeah,
so
I won't tell you what I'm doing. I'm going to meet the guys for a beer and some food.
Oh, what a great idea.
So
Hey,
my-
Arne, I was thinking that since you recorded this session, do you think you can make available the link in
Yes, I
the
can.
Google Calendar invitation so that everyone who registered just has to check the link and they can watch the full video? Is that okay?
Yes, of course. I saved it in the cloud. Unfortunately, we missed the beginning, but I guess we got the majority of the Q&A.
Okay, awesome. Thank you so
Excellent.
much.
Okay.
Thanks
All right.
very much,
Then
guys.
you have a good day and a good evening.
Cheers,
Excellent.
everyone.
Thank you.
Bye.
Thank you so much.
Thanks
See you.
very
Nice
much.
to meet you, Andrew.
Bye-bye.
Bye.
Bye.
Thank you.